There's trouble at Mill. Fire has broken out dangerously close to the Rough Science base. Can the team use science to extinguish the flames before it's too late? Our 4 pioneering scientists are Ellen Macaulay, an intrepid go-anywhere botanist with a love of all things wild. Mike Bullivant, a chemistry wizard with a wicked sense of humour. Jonathan Hare, the do-it-all inventor, physicist and engineer. And Hermione Coburn, an earth scientist and explorer who never gives up. Their base is an abandoned mining mill way up in the mountains of Colorado. This is High Altitude Rough Science. Last week, the team equipped the mill with gas and electricity. But with a ramshackle old wooden building as a base, fire is a very real danger. In 2002, much of this region was ravaged by a huge forest fire. But that's not the only hazard in these parts. 100 years of mining have taken their environmental toll and polluted some of the rivers to such an extent that they can no longer support any forms of aquatic life. So this week, our scientists face a battle on 2 fronts, one against fire and the other against pollution. Right, so this week, you're going to be tackling 2 environmental hazards. Now, as you know, this is an area that is very prone to wildfires, either from lightning or people being stupid. So, what we need you to do is come up with a way of extinguishing fires. Any brainwaves?
Fire extinguisher.
Wow, you're good! So early in the morning. Are you going to knock us off a fire extinguisher then?
Mike will do it.
That's not so crazy.
We'll do it.
Do you think you could do it? Yeah. OK, fine. All right. I know, nice red one with a squirty thing. That'd be very good. And the other thing, and this is going to have to be down to you two now, okay. Is the water problem. Now, you may have noticed that the river down here looks beautiful, clean, pristine. It isn't. What would be great is if you could come up with some sort of system to stop those rivers being polluted so that they can support life again.
Sounds like we've got to build a water treatment plant.
Of course you have. Just like that.
OK, and then I'll help you.
Yeah, I can I love it. So we're going to have a water treatment plant and a fire extinguisher in 3 days from anything that you can find in the mill and any natural resources you want to plunder. Good, off you go then. Now, Mikey B, this fire extinguisher, you're not just going to give me a bucket of water and say, done it, are you?
Nope.
OK, what are you going to do?
We're going to produce carbon dioxide.
Right. And why is that going to work?
Well, it's the principle behind a lot of fire extinguishers.
Yeah.
Carbon dioxide is a non-toxic gas. It doesn't support combustion.
Which is a good
flames
thing.
Out.
Yeah.
And it's heavier than air.
Right.
So it settles on fires.
So it effectively smothers the fire, does it?
Yes, yeah, it takes away the oxygen in the air for combustion.
OK. So how are you going to make carbon dioxide?
There's a simple way.
Right.
Have a look at this. Sodium bicarbonate in there, and if I add an acid to that, it'll generate carbon dioxide. Now, the sodium bicarbonate, it's a natural resource around here.
OK.
But it's thousands of feet underground, so I'm just using baking soda.
Very sensible idea. Otherwise, I'd have a horrible feeling you get me to do the digging.
Yeah. And I'm going to use vinegar, which is a mild acid.
OK.
Now, watch what happens when I add the vinegar to the sodium bicarbonate. It fizzes up, it produces carbon dioxide.
Yeah.
Put a bit around the side, too. Now, as it generates carbon dioxide, carbon dioxide is heavier than air. It puts the shorter candle out before it will put out the longer candle.
Oh, that's gone too?
Yeah.
So basically, you've got your baking soda, you've got your vinegar, it's made carbon dioxide, it's absolutely proved it, you've got your components.
Yeah.
That's it, is it?
We could do better than that.
OK.
If I'm going to try and make a stronger acid than vinegar.
Right.
Because then we'll get more carbon dioxide, we'll get more pressure inside the fire extinguisher.
So, any thoughts about how to make a stronger acid?
The rocks that I can make acid from out in their hills over there.
Really?
Yeah. So I've got to go out collecting and crushing.
So Mike is off in search of rocks that'll make an acid stronger than vinegar, while I take Ellen and Hermione to an abandoned mine to find out just what's causing all that river pollution.
This mine hasn't been active for over 80 years. So what I don't understand is why it's still polluting the area.
Well, what we're seeing is actually the result of a natural process. It's not as though they themselves brought in any chemicals to the mine.
So this isn't a result of miners using, I don't know, cyanide or something to extract metals from rocks?
No, that's right. This is something that occurs naturally.
Yeah.
Essentially, what's happening is these rocks are rich in iron sulfide, that's pyrite. And when pyrite comes into contact with water and oxygen, it breaks down to release iron into the water and to form sulfuric acid.
Right.
And so this water that's coming out the mine, I suspect is acidic, but it also has a very high iron content, and you can see that because it precipitates out as this yellow coating on the rocks.
Right. OK. But if this was a natural process, surely the environment should be able to cope with that.
Well, that's because it's different from just it happening naturally. Humans have gotten involved, hacked in these huge holes, deep holes into the earth, and really exposed a lot of rock.
Right.
And they've also chipped away veins, allowing a lot more water to pour through, too. And so instead of having it on a small scale, it's now on a huge scale.
OK, so now that you have seen what you're up against, what's your next step?
We're going to collect some samples.
And test the water.
OK, do you want to hand collect it?
Yes, please.
We're collecting water. Mike is out collecting rocks. He's on an old tailings pile. This is the stuff that gold miners have thrown away, but it's got just the rock that Mike is after.
It's called fool's gold. I don't know why I've been sent to look for it, but hey-ho. Ah, here we are. Look at this. Isn't this beautiful? This is fool's gold. Iron pyrite.
Now, where have I heard that before?
So let's start bashing away, harvesting the pyrite.
So the rock Mike is collecting is the same one that's polluting the mine water. And back at the mill, Ellen and Hermione are finding out just how toxic that water really is. Ellen has collected some microscopic animals from a local pond to see how they react to the mine water.
OK, so how are these tests going?
Well, this is the test for toxicity to aquatic life. And I've put some Daphnia in.
Yeah.
And they're dead.
What are Daphnia?
They're little water fleas.
Oh, those tiny little, very dead-looking things at the bottom of there.
But if you look in the clean water...
They're all hopping up and down.
Yes, they're jumping around. So we know that the mine water is toxic to aquatic organisms because Daphnia are pretty sensitive.
So we know that this water is toxic to water fleas. Do we know why?
Well, we suspect that it's acidic.
Right.
I haven't done the pH test yet.
OK.
So I'm going to do that now.
So good clean water would be what sort of pH, roughly?
A typical mountain stream should be around about 7. Now, if it's acidic, it's going to have a pH lower than that.
OK. So we're looking at kind of, if it were good, it would be yellow.
No.
So we're looking at it to be orange or kind of pinky colour. Ooh, that's very dark. I'd say that's almost 3 or 4 on there, would you?
Yeah.
No wonder the poor little things are all at the bottom with their legs in the air.
Yeah, and the other thing is when you have that kind of acidic water going through that kind of rock, there's got to be a lot of metals in there.
OK, so you've got acidity and a high level of metals. What on earth can you do to change that?
Well, I think I can have a go at the acidity using an alkaline rock, limestone, which is calcium carbonate.
Right.
And by passing the mine water through crushed limestone, I think that's going to help neutralise the acid.
OK, but what about all that metal? I mean, all that yellow that we saw over the rocks up at the mine?
Well, part of what can remove the metals is actually bacteria.
Really? But I thought bacteria would make it worse.
Yeah, a lot of times we think of bacteria as being negative.
Yeah,
but
absolutely.
in this case, they can really help us out.
Hermione goes off in search of rocks that will neutralise acid, while Mike and Jonathan are busy turning rocks into acid.
Before you do anything with that, Mike, what have you got in there?
This is iron pyrites, iron disulfide.
Is this what you chipped off the rocks you collected?
Ground it to a fine powder.
What sort of acid is it you need?
Sulfuric acid.
Sulfuric acid.
Yeah.
So this is your stronger version of the vinegar.
Yeah, this will produce much more carbon dioxide at a higher
Okay.
pressure. What we've got to do is heat this.
Right.
And have air passing over it. We produce a gas by heating the iron disulfide in air.
Right.
And the gas passes through water in these two containers. and it
Okay, so
dissolves in the vinegar.
those two containers will end up being sulfuric acid.
Exactly, yeah.
Hang on, that's all sounding quite familiar. So you're using air and water to break down the pyrite. Isn't that exactly what's happened to the mine water? Isn't that exactly what Hermione and Ellen are trying to reverse effectively?
Yeah, this is just a fast version of what's been going on in the mine, yeah.
So that's how you make acid. Meanwhile, Hermione's trying to reduce acidity. First, she has to crush the limestone she's collected. Then she adds a sample of the mine water. But what has Ellen got in that dustbin?
All I need is a little bacteria. And where's a great place to get it? Manure. Well, this is horse manure. It's nice, fresh, and juicy.
Now it's almost time to get the acid production underway.
I don't understand why you've got this big thing of water. How's that going to work?
Well, basically, this is full of water.
Yeah.
If I open the tap,
Yeah.
obviously gravity makes the water flow out.
Yeah.
So that produces basically a vacuum in here. So it sucks the air through the system.
Oh, okay.
So it's just the weight of the water moving down. So when I open this tap,
Yeah.
these should start bubbling because it's drawing air through the system. So if I turn it on,
Yeah.
that's...
Oh, yeah, it's bubbling almost instantly. Look at that.
Next, Mike needs to heat the pyrite. Jonathan's pump is sucking air through the system so that the pyrite is exposed to lots of oxygen. As the pyrite breaks down, it gives off acidic fumes. This gas bubbles through the jars of water where it dissolves, hopefully turning the water into sulfuric acid. As day one draws to a close, I leave Jonathan and Mike to their chemical labours.
Well, it's the end of day one of the water treatment challenge. And I'm really excited about this one because Ellen and I are tackling a real environmental problem.
But I'm very confident that we've got some acid, and it's just as well because without any acid, there'd be no fire extinguisher at the end of day 3. So fingers crossed again.
It's day 2 and the boys are up early.
So, you're going to do the acid test. So if this goes a sort of orangey or pinky colour, it's basically a success.
Yes.
Okay.
See?
Oh, wow! That is unquestionably acid. That's pH 1, isn't it?
pH 1.
Fantastic. So is that just going to make you loads and loads of carbon dioxide? Brilliant. Brilliant. Well done, though. That's great. Look at that.
Success for Mike and Jonathan. But how's the mine water? Have the manure and limestone worked?
So do you want to test the mine water?
Okay. We put them in at the same time. In it goes.
If this is 7, it should be yellowish.
And mine should still be that sort of dark orangey colour.
Okay, ready?
Look, I can see the difference already.
Wow, look at that.
That's amazing.
Pretty good. So, well, mine's sort of 6 to 7.
Yeah, so it's pretty good. Basically, that indicates that the limestone is doing the right thing, is basically neutralising that acid.
Yes.
Well, you're going to have to presumably go and dig out a lot of rocks.
Yeah.
Okay. Call me when they're already up by the mine, will you? I'm not going to carry them up the slope. Now then, let's have a look. What do I say about this? Can I say that you have made it look considerably worse than it did yesterday?
And that's good.
Is it?
Yes, because
Okay.
we want the bacteria to be reactive.
Okay,
Yeah.
but how on earth are you going to be able to tell that they've worked?